Hello, everyone, and welcome back. My name is Mr. Kovalt, and today we are going to be going over the periodic table and how it is structured so we can get to know and use it. So I am sitting down today because I had to bring this closer. If I stand up, then you're really not going to see me. So I want to make sure you guys can see the periodic tables as I go over it. So let me adjust this a little bit. I guess that's as good as it's going to get. Um, okay, so the periodic table is called the periodic table because there is a what is called a periodicity to the periodic table. And what do we mean by periodicity? Well, it comes from the word period. And a period is just another word for a cycle, right? So if something is periodic, then it's cyclical. It happens over and over again in a particular time period. So think about those of you who are familiar with physics, who have learned about the period of a pendulum. The pendulum swings back and forth, and we call one revolution a period. So it goes here, and then here, that's one period, so one cycle, right? So there's a cyclic nature to the periodic table, and this comes from an observation that Mendeleev, who is the father of the periodic table, saw. And he put the periodic table together, or he put the elements together according to his observation of how they react, similar properties, as well as according to the mass or the atomic masses of the elements. So even though at the time that Mendeleev was alive, they didn't know anything about subatomic particles, but they were still able to calculate atomic masses of the atoms, right? So they could find the atomic masses, and then so Mendeleev used his knowledge of the similar properties of elements, as well as what was published at the time regarding the atomic masses of elements. And so what he did is he put them into groups. This is not very. This is not the periodic table that he had. His was much smaller. His only had like I forget exactly how many, but it was like 50. It was somewhere around there. So we have about 100 or so elements, 118 elements. So we have a lot more than he does. But he, based on what was published regarding his observations and others' observations regarding their similarity in reactivity. So if they had similar properties, then he put them into groups or what are also called families, right? So I have written over here that a group or family is what is the column of the periodic table going up and down. And you can think about it be called a family because people in families have similar characteristics. They look the same. You might say, oh, he looks more like the father than the mother, or vice versa. Or the two siblings have very common characteristics. So that's probably the reason why we call them families, is because elements in the same column are going to have very similar properties. They're going to form the same sorts of products. They're going to react the same way with various elements, so on and so forth. So one example is you could say that the elements in this group might react very strongly with water. They all react with water to form hydrogen gas, and that is a common property. So they would be put into the same family. Um, so, so there's a periodic nature to the periodic table, and so when you go across the periodic table, you'll get certain characteristics of this element, and then this element will have certain characteristics that are a little different than this, right? So this will form certain products, then this will form different products and do different reactants. And then you come over here, and then this one, again, will react differently in different situations, and so on. So you notice that each element will react differently. This element doesn't react at all, so it's inert. It has no activity. But then if you're following the mass, so the mass is increasing this way. This is the way he put it, Mendeleev. So you're ordering them according to mass, and then you get to the inert, and then the next one that is the more heavier element after this element has very similar properties to this element. So he put it there in line with the element that also has those properties. It's heavier, so it goes on the bottom. And then the next heavier element has similar properties to the one above, so put it there. And then so on and so forth. So this element is next, and this element, and so on and so forth. And so you see a cyclical pattern. So when you get to this element here, you get inert. And then when you follow the next one that has the next mass, has similar properties to these two, and so on. So you get a cyclical pattern. So this is why the periodic table is organized in what is called periods. So each row I have written here is a period. So if you're going this way, these are periods, and they're numbered 1, 2, 3, 4, 5, 6, 7. So first period, second period, third period, fourth period, and so on. And you'll see that the groups or families are also numbered. So there's two different numbering systems. There's a historical basis for this, and I'm not going to get into that. But there is a 1 through 18 numbering, so all of the groups are numbered 1 through 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Right? So that's one way to name it, but there's also a numbering system according to A and B. So you have the A's, so this is group 1A, this is group 2A, and then you skip this middle part, and then this would be 3A, 4A, 5A, 6A, 7A, and 8A. And then in the middle here, these would be lettered B. So you'll see that it's 3B, 4B, 5B, 6B, 7B. It matches with the numbers here. And then for some reason they have this as 8B. Again, I'm not going to get into that. And then 1B, 2B. So the elements here are your B elements, and the elements here are your A elements. Okay. So what else do I want to point out here? So the A groups or families, these are referred to as your main group elements, or they're also referred to as the representative elements. Or so the groups 1A and 2A and groups 3A through 8A are your representative elements, or what are also called the main group elements. And then the elements in the middle, your B group elements, are referred to as the transition elements. Okay, so you got to remember these are transition elements. These are your main group elements. Now here, I forgot to write it down. I'll write it down now. This group here is actually inserted in here, but usually it's down here at the bottom, because if you insert it, then the table gets too long to put on a separate sheet of paper. But know that this is actually inserted here. So this breaks up and becomes wider. These are called your, I have it written here. These are called your inner transition elements. And so inner transition because they go inside the transition elements. This particular row here is called your lanthanides because they follow lanthanum. And these guys are called your actinides because they follow actinium, right? So if I put in LA and AC. So these guys would be inserted after these two. Okay, so we have our transition elements, main group or representative elements, inner transition elements. Okay, what else can I point out here? Certain groups of elements are going to have special names, and these are names you're going to want to know. So group 1A, those are called your alkali metals. They have particular characteristics. We'll get into that later. The group 2A here, these are called your alkaline earth metals. So you have your alkali metals 1A, alkaline earth metals 2A, and then over here you have in this 7A group, these are called your halogens. And this last group here, 8A, these are called your noble gases. These are noble gases, or they're also called inert gases. They don't react at all with anything, at least not under normal conditions. Okay, so the last thing I want to talk about is the division in the periodic table according to not phase, but type of element. Is it a metal, non-metal, or metalloid? Most of the periodic table, if you see here, we have this stairway here that I blackened out. So this little stairway here separates the table into metals and non-metals. So the red here I have marked as metals. So you can see that by and large, more than 2/3 of the table is metals. And then here in the green, I have as non-metals. So everything on this side is non-metals, and everything on this side, except for this one, this is hydrogen, is a metal. Hydrogen's a non-metal. Everything else is a metal on this side. Okay, so what about this group here? So you'll notice that the elements that are on the stairway, except for this one, that's aluminum. Aluminum is a metal. We are all familiar with aluminum as a metal. So these guys, if they're on the stairway, you'll notice they're not on the corner. So here's a corner. The ones not on the corner, but they're on the stairway. They are kind of hugged by two sides of the stairs. So you'll notice that if you're hugged by two sides of the stair, that they're written in, except for this one here. So these guys are what we call the metalloids. Now, to remember what a metalloid is, you think about, okay, what is a metalloid? Think about what a humanoid is. Humanoid is something, an organism that is human-like, not quite human, but has human characteristics, so we might call it a humanoid, right? So metalloid is the same thing. Metalloid are elements that behave like metals, but they're not metals. So metalloids are between non-metals and metals. So these guys have properties of both metals and non-metals. And these guys, the metalloids, are where we get our semiconductors from, right? So you can see that silicon is a very famous and very popular semiconductor, so that's used, and it's a metalloid. So these are the metalloids. These are your non-metals. These are your metals. Okay, I think that was everything I wanted to talk about. Thanks for joining me. I hope this was insightful. If you enjoyed this video, please share it with other people. Subscribe to the channel. Make a comment down in the comment section. Ask me to go over anything you want. And ring the notification bell so you get notifications. Thanks for joining me, and I'll see you guys next time.